Okay, so there are a lot of different calibrations you can do on your system. I know a lot of people have asked about doing this, and I really wanted to, document this when I had a chance to do it. So I'm going to go ahead and do that now. Okay, so if you find your calibrations panel, the magnification one, now you have to be logged in under supervisor level or service level to see this, okay? But you can see these are all the different magnification calibrations, okay? So the one that we're going to do is Microprobe STEM, okay? So there's different for Microprobe STEM, for HM STEM, which is when we which is nanoprobe, right? And then LM STEM as well. So these all have their own separate routine. So we just did the alignment for Microprobe STEM, and you definitely need to do that before you do this calibration, but you also need to have STEM mode properly tuned up as well, okay? So you need to have done your corrector tuning and that be in good shape as well, because that actually is the initial start when you do the mag cal in Microprobe. I know that seems kind of counterintuitive, but it's actually the case, okay? So what conditions do we use here? So we still have the 50 micron aperture in. It doesn't matter which one of these you use, but I'm going to put in the 70 because it's going to make it a little easier to actually to tune up the images that way. So let me go back here, and I'm going to check my, let me center the beam shift here. Turn off C3. Okay, that's reasonably close. All right, so I think that's not too bad. Okay, so now I'm going to put the mono at negative initially here, and when we need to switch that back for doing microprobe, we can do that, okay? But just to start with, I'm going to put that at positive because that's what we typically do when we're doing STEM. What I'm finding here at 60 kilovolts is I'm making the extremes a little bit higher, plus or minus 50 actually, because otherwise I'm seeing the beam getting or not fully illuminating the aperture rim. All right, so we are good there, and so now we can go into, we can go into calibrations, find our Microprobe STEM calibration, and click Start. So the first thing it's going to do is it's going to put us into regular STEM mode. And I believe what it does is, okay, so it's actually, that's interesting. We're in STEM, but it's got the C3 off for some reason. So it shouldn't be doing that. This is a little bit of a glitch. This should be in, oh, I know why. Oh, hold on a second. Let me click stop here, my bad. Okay. Are we still in STEM mode? Okay. Okay, I know why, my bad. Okay, so, okay, make sure, right? Go back to 3 condenser mode when you start. Okay, that's why it did that. All right, and now we can go back and do this. Okay, all right, find it from the list, click start, there we go, okay. Okay, perfect. All right, so now we need to align normal STEM at these conditions, okay? Now you can change this if you want, we're just gonna leave it here anyway. So I'm gonna turn off diffraction. And let's see here. We're going to look for the beam. Actually, okay, what I'm going to do here is I'm going to start acquiring. We can center the beam. I've got diffraction off, but that's fine. Okay, there we go. All right, there we go. Go back to Velox, take out the hadif. Okay, and now again, we don't want to get out of this panel because if we do, we're going to stop the calibration. So we're going to find direct alignments, intensity list focus. We're going to freeze that somewhere about there. Okay, and so we've got some definite twofold astigmatism. So we're going to pull S-core up here, ATA1. Okay, that's good enough right there. As far as this being off-center, we can leave that alone for now because I'm going to show you what to do for that in a second. Turn diffraction back on. Okay, bringing the sample up here. Piezo reset. Okay, so we've got some axial coma. Find the stigmator panel, click probe B2, and we can go ahead and fix this now, A2, B2. Is it doing anything? No, it's on bit multiplier 0. That's why. Okay. Is it doing anything? Yes, it is. Okay, wrong way. There we go. Inching up on it. Okay, that looks good right there. Click none. Okay, now if there's any more. Okay, we'll leave that alone for now. And sorry, it's a little tough to do with one screen. Okay, that looks good. And we'll go back to acquisition and start. Okay. So now we want to be over an area where the squares are good quality. So something like this would be good right here. As far as the beam tilt here, so we can actually do this by, where are you? Just by minimization here, by looking at, I mean, this is already pretty close here, but you're just looking at shifting of the image here. Again, this is beam tilt here, so you can see, what is that? Let's put that on bit depth 3. Okay, so you can see shifting up and down. Okay, that's shifting side to side. Okay, that looks good enough right there. Okay. Okay, so it looks like we've still got maybe some axial coma here. Okay, let's go ahead and fix that. There we go. That looks pretty good. Okay, and now the last thing, we can use fine condenser here to get rid of any streaking we have left. Here in the ronchogram. Okay, that looks pretty good. All right, and then let's go back to Velox now. Okay, much better. All right, now we don't need this. This doesn't have to be good down to atomic resolution, because it's doing this for microprobe. Remember, okay? But it does need to be, decent, okay? And that's decent here. All right. So now at this point, we can stop this, and let me do one more direct alignment and center the seabed pattern. Okay. All right, and then we'll click next, center a good area, and then press next. Okay. We are focused here. I haven't moved the focus at all. I've been focusing just with the piezo, right? You can see very clearly right about there. See, why does it look like it's... Oh, that's because I'm magged way out, so okay, no big deal. Okay, so we'll go ahead and click next here. Okay, so now it's going to acquire . anyways, it should be acquiring an image in HM STEM calibration procedure failed. All right, let's try this again here. Okay, this should all still be good because we didn't swap out of the mode here. Okay, next. Next. So it's not acquiring an image here for some reason. Why isn't it doing that? Okay, what we may need to do here is actually start the image in Velox. There we go. Okay. All right, let's see if that... Okay, there we go. So we had to start it first. I know normally it does that automatically, so I don't know why it gave me a problem that time. So it's doing an analysis of the cross grading and correcting this. So it starts this in STEM mode here first, okay, and that looks perfect. So we'll click next. Now what I've seen with this is sometimes it actually misidentifies this by 45 degrees. So you do want to make sure that it actually is correct. All right, next. Okay, now it's going to switch into MicroProbe. So now, unfortunately, what we have to do is we've got to align MicroProbe now, okay? So we'll turn off diffraction so we can look at the probe, and this should be a lot faster than what we just did, thankfully. Okay, and take out the detector. There's my beam here. Okay, so okay. So now, unfortunately, what we have to do here, it turned off the C3 lens. I don't know why it does that. Sometimes it does this randomly. Okay, so we need to switch to we'll switch to probe, and then free control, and then microprobe. Okay, there we go. Again, normally this is sometimes glitchy like this. Okay, but that already looks good because we just did all those alignments. So, all right, so what we can do here, now our sample height's going to be different. You can see that the image is not in focus here, so we're actually going to move it down, something about like this. And the pivot point should be okay. We'll go ahead and just check it anyway here. Okay, so those are off. Well, that's because of the well, here, let me do intensity list. Whoops, nope. Okay, intensity list focus. Okay. Okay, so we want those two tips to touch there. Just like that. And just like that. Okay, and then rotation center. Okay, looks good. Mag up here. Okay, there's a little bit of astigmatism, so I'm going to turn on condensers, stigmators. And that looks good right there. Stigmator off, intensity list done, diffraction on. Okay, and we'll acquire our image here. We'll start in Velox. So now we want to focus with Z as much as we can here. So I still have the piezo move Z for this. Okay, it's giving me end of range. Okay, so I think it's getting, again, at microprobe, yeah, so that's getting worse. In nanoprobe, or microprobe, your depth of field is pretty high here. We're not going to get atomic resolution, obviously. Let's see here, as far as the focus. Yeah, so we're getting good focus with just, a few tens of nanometers of focus, so. If there was any astigmatism in the image, we could correct that, but that looks okay. All right. We might have a little too much gain, but we'll leave that there for now. Okay, so now if we go back here, okay, press next to continue. Okay, we're in a good area. Okay, we have the image focused. So now I don't want to mess up this, so I'm going to start searching already here. Let me switch to preview. Okay. So yep, we already checked the focus, so we should be good. And we'll click next. Okay, so it'll automatically adjust this. We want about 20 cross gradings in it, so that should be good enough right there. And we'll click next. Okay, so it's checking for the distortion, just like it did previously, to make sure our squares are squares. I once had a cross grading that didn't work very well for this because it was very asymmetric with its distribution, and it gave me a lot of problems. All right, so that looks good. And now it's going to do the calibration. So it moves the stage as part of this. Then once this is done, we can actually, there's a way we can check the calibration. So, because each of these squares is 467 nanometers. And so we can actually verify that. It's doing cross correlation, found the peak there. Okay, so now it's measuring the Y shift. Okay. Next. Successful. Accept. Okay. Then it puts us back into normal STEM. So now let's check this. So I'm going to go back to Beam Tune, MicroProbe, and since we were just at this setting, you know what I didn't do? I don't think this is going to, this won't make a huge difference. I didn't put the mono back to -40. I'll go ahead and switch this back just so I can show you that it won't here though. So, all right, we'll turn diffraction off so we can see this. Okay, so focus. All right, -50. And there we go. All right. Everything should still be good since we just did this. So yeah, you can see the rotation center is basically still okay. Again, when you switch between modes though, there's going to be a little hysteresis. So okay, there we go. Intensity list focus. Okay, probe looks nice and circular, so I'm not going to worry about that. Okay, good. All right, diffraction on. All right, let's see what we got here. Okay. Okay, yeah, barely any to focus, so that's good. All right, so I'm going to mag out so I can see several of these cross gradings like this. And I'm going to increase my pixel size here. Now what we should see in the FFT here, okay, so let me switch it back because we're seeing too small of a view field here. Okay, there we go. Okay, so basically here's the FFT, right? So now if we want to see this actually, let me mag out more so we can see, there we go. It's going to make this easier. Okay, there we go, because we're seeing a lot. So basically you can see, whoops, sorry. Okay, let me scroll in with FFT, right? So you can see these four closest spots here, these are for 467 nanometers. You can see the ring is going right through it, okay? So it did the MagCal perfectly, right? This is one of the reasons the FFT is great for measuring spacing, right? Because especially with something like this, it's kind of ambiguous where one starts and stops. But if you do the Fourier transform, you get these nice defined spots, and then it's really obvious where a spot center is, okay? So anyways, we verified that the MagCal is good, okay? And of course, it didn't hurt us that we had the mono set positive because I put it negative here as we would normally do it, and everything looks perfectly fine. Okay, so that was the video I wanted to do on doing the MagCal. Now it's also going to pull up this window here calibration log when you do the mag calibration. Okay, when you're done, you can just close it. So, all right, and so with that, that concludes the video on doing STEM-MicroProbe magnification calibration. It's very similar to do the one for HM STEM. Obviously, you're only going into one mode in that case. All right, take care, everybody.